state-of-the-art methodologies that exist. And we will introduce a few case studies that we have been developing, mostly in the Mediterranean. With a final case study, we are currently developing exclusive economic zone. So first of all, the outline, we will look at what is marine spatial planning, some definitions and what is used for and why it is useful to have marine spatial planning. We will have a look at some decision support tools, and we will look at different case studies, try to draw us a big picture on what is the state of development of these tools, how can they be used, and how they can basically also be further improved. So there are different definitions for marine spatial planning. There are international organizations like the UNESCO IOC, which is providing a definition of marine spatial planning as an approach that that applies basically ecosystem-based management approach to marine areas, with the main aim to analyze and allocate the spatial temporal distribution of human activities at sea, and identify, achieve ecological, economic, social goals within those areas. The European Union defines marine spatial planning actually as a process which is relevant for coastal countries of the European Union and has the aim to organize human activities and marine areas. The DEFRA, which is a national institution from UK, defines marine spatial planning actually as a rational organization of the use of the sea, with particular attention on the interaction between users and the demand and the sea space demand of different users. What is really important is actually that there is a much more, let's say, operational definition, which actually refers to the agreed plan should actually provide a firm basis and rationale actually for decision making and to provide, for instance, license application for different users. We at the European Union level, we have the Marine Spatial Planning Directive, which was developed in 2014, which actually applies ecosystem-based, has the aim to apply ecosystem-based approach to sea areas and therefore balance ecological resources and ecological goods and benefits to the human activities that occur at sea. It should contribute to the preservation and protection and improvement of the environment. It should, of course, pursue additional objectives, like the development of tourism, potential new use of material and extraction of materials. It has the aim to promote coexistence between different users and activities. And of course, it has the aim to foster sustainable development by developing energies that have potential for decarbonization of the environment, for instance, so offshore wind energy and ocean energies in terms of wave or tidal energy, maritime transport, and of course, food production in terms of fishery and aquaculture. What are here the obligations of marine spatial planning? It is basically, so countries have to set up a marine spatial plan. They have to set up a competent authority, so a responsive authority. Some countries develop their own authority for the management of the marine space. Others basically integrate existing government structures like existing ministries for the development, and there's competent authorities for that. And it is a public participation should be ensured already at the beginning of the plans. The time frame is starting from 2014, and now we are in the year basically where the marine spatial plans, or most of the marine spatial plans, should be basically submitted to European Union. What are the benefits of marine spatial plan? The benefit of marine spatial plan is basically to reduce conflicts at sea, and particularly by coordinating sea users and have a conscious use of marine resources. It encourages investments. So by creating predictability, transparency, and clear rules on how to use the sea space, and creating basically necessary legal frameworks on how the sea should be used. It should increase, of course, cross-border cooperation among different countries by developing joint shipping lanes, potential energy grids, joint energy grids, and of course also networks of protected areas. And of course, protect the environment through the early identification of potential criticalities and risks to the environment, and identification of opportunities for new users and for multiple users of the sea. Here just to show that marine spatial planning is actually a global process. In particularly, It has a global momentum. So these are the areas of the world, the seas of the world, where marine spatial planning is not developed, or at an early stage, or has been already implemented. So this is from 2019. So we have here mostly yellow, which is showing basically European countries are most underway in the development, while there are countries which have approved special plans and already have new cycle of development of marine special plans. This is some key literature, which is basically a guideline on how marine special plans should be implemented in a step-by-step approach, which is basically this one. This is taken from this literature. What is important is that it identifies that the marine spatial planning is a process, it has different steps, basically actually 10, which we will not go into detail into those, but just to say that the first step is defining context and marine authorities responsible for it, identify financial support to develop the plans, organize the marine spatial planning process and the pre-planning, organize the stakeholder participation, define what are the current conditions of the sea, the environmental conditions, biophysical conditions, and the human activity conditions. Identify what are future conditions at sea. So what are future environmental conditions, climate change effects, but also identify how new technologies may require space at sea. Developing then the marine spatial plan, implementing and enforcing the plan, having monitoring and evaluation how this plan was developed, and then adapting the marine spatial plan through a legal framework. This is an iterative process because it's a first cycle process and then you can go into second cycle process. This depends on the country, and it's usually defined every 5 years or 2 years, depending on the needs. The support tools particularly are important for different steps in the planning process, and I leave now the floor to Dr. Stefano Menegon, which will particularly focus on the instruments that support participatory approach and allow to analyze current and future conditions.
Yeah. Is it okay? Okay. So now we are going to go more in detail in which are the main decision support tools that can support these processes. And a few, just to introduce my research group. We have, I worked at the National Institute, in the National Research Council, Institute of Marine Sciences, in a group that is called Tools for Supporting Maritime Spatial Planning. So the name is quite significant in this way. And our group in interdisciplinary technologists, and planners, and so on. And the main focus is on marine management strategies, maritime spatial plan, integrated coastal zone management, that are all processes that implement decision-making processes. And within, in our groups, starting from about 2013, we have carried out an activity, a strong activity in this aspect. And following a lot, supporting a lot of, participating to a lot of EU funding projects. From AgriPlan was the first project that was a pilot study for the MSP in the Adriatic Ionian region, to the last two projects that are through Horizon 2020, the Saturn, where we are going to investigate the underwater noise in EU seas, and the last one is these both are ongoing projects. And the last is another Horizon 2020, is a Bridge BS, where we are going to apply our technology to Black Sea, and investigate the impact in the Black Sea and support the decision-making process there. So within these projects, we are also implement a set of tools, software tools, web tools to support our activities, and especially we also make this tool as a release as open source in order to make available to the community of professionals and scientists. This is more or less the area where we apply, we are working in project, and where we have applied the tools. The tools can be, just to give you a first idea, can be tools to, the first basic tool are the geoportals, the data infrastructure, to organize the information. This is a quite important basic tool. And tool for investigate the anthropogenic pressures on the sea environment, to investigate the effects of the anthropogenic uses, to assess the maritime use conflicts, the ecosystem services, but also to stakeholder engagements that we will see in a moment. So, as Daniel said before, the MSP process is a quite complex process. This is the reason why tools are needed. It's a quite complex process. There are multi-actors that different skills, for example, the scientists may have some more technical skill to analyze the data, to investigate the problem, but the process are also to involve the citizens, the stakeholders, and the public administration that usually has different skills. So we have to put all these groups of users together and to implement a process that also is quite complicated. There are a lot of stages and it takes a lot of years usually to implement it. And there is a lot of data information that we have to collect and to manage to make it available. So this is the reason that usually we need some tool to support these activities. And we call it decision support tools. So we refer to a wide range of computer-based tools. For example, simulation model to investigate the dispersion of pollutants or some techniques and methods to support the decision, to investigate the problem, identify the main issues. It could be database to collect information, model to perform the analysis, or graphical user interfaces to facilitate the non-expert user the analysis and the visualization of information. And the main aim is to support the decision-making process, but also to make this process more transparent, to make the information persistent in the time. So at each time we want to recover it with the initial information that provide our decision. This is quite important. And to provide easy access to information also to non-specialists. It's another tricky aspect of the problem. But also to vehicle for communication, training, and in general the involvement of entire community for users. So today we are going to see three, it's just a selection of the tool that we have developed. Three main tools. One is the collaborative geoportals and data infrastructures. The second one is a tool for the stakeholder engagements. And the third is a tool that we have developed from the beginning of our experience, the tool for assess the cumulative effects of anthropogenic, which is over the Marian Sea. These three tools are web interactive tools that for engaging the entire community of MS users. So this is the first tool. I took this example is the output, the main output of the Porto di Mare project is Interreg Adrian project just concluded. That created this infrastructure, this portal to access relevant information for MSP process in the Adriatic Ionian region. This is just an example. We can implement the same things in other areas. So this is quite important infrastructure because can allow the data producer to put the information in one single portal and to make it available to the other users, to make this information persist in the time. We can re-access the same information over the entire process. And so facilitating the transparency because we also try to foster, to facilitate the publish of the information as open source data, open data. And this kind of portal are also interoperable, as we will see in a moment. By the way, you can see if you enter into the portal, you have provided a URL here to facilitate you. You can, at the beginning, search for all available information that are categorized by topic categories, other metadata that are quite important to understand which kind of data is contained in the portal. So you can filter and extract the information. For each layer, you have a form, but also a preview. You can navigate the layer, query, download, inspect the metadata, and understand the best way to use this information also for your analysis. You can create a new map. The end user can combine the data present in the platform to create a specific map that containing more than one layer together. For example, this example for maritime transport in the Northern Adriatic, where more than one layer are put together to provide a point of view of this aspect in the Northern Adriatic. This is another example of map that we have provided for the Faros for MPA project that was involved also the Professor Lloret from the University. Within our platform, we have created a lot of this map to inspect specific aspects to support marine protected area management during the project. You can use this map to put in publication, to share with other colleagues, and because this map can then tell the general plan. Another aspect, the last important aspect of this infrastructure is the interoperability. So the data can be accessed through interoperability service. This facilitates the connection with our platform with already established infrastructure at the European level. Maybe you already know about IMODNet. It's a quite important infrastructure at European level that provide information for the marine seas. For the marine areas and the European seas, you can find information about the human uses that are present in the area, the chemistry, the biological aspects, and so on. So using these interoperable services, you can connect all this information together and, for example, publish a map that contains everything. But there are also connections with Copernicus for satellite data and monitoring services and climate change services, or other portals like Hobbies or GBIF that can contain biodiversity data. The second tool that I would like to present is this tool for the stakeholder engagement. It is called MSP Challenge Game. It is developed by the Bauhaus University, the Breda University of Applied Sciences. But in this year, in April 2021, we have developed in collaboration with the university a specific edition of this challenge games for the Adriatic Sea. This one is the edition for the Adriatic Sea. Basically, this games was originally developed as a board game where practically the user was put around a table, and it was a tool for teaching, for training the user in understand how the MSP process works, to perform stakeholder engagement, and in parallel with the board game, the Breda University have developed also the online, the digital one, the software where you can, because the board game is just an example with artificial areas. Instead, they also developed the software game where they have put the real case study for some edition. They already have the North Sea and other edition. Now, from this year, there's also the edition for the Adriatic Sea. And we have used this tool also in the Italian MSP process to engage some categories, especially public administrations, at the beginning of the project to teach them how the process works and which way they can contribute to the process. Now, another important thing of this tool is that the data are automatically uploaded from the geoportal, in the data infrastructure that I have just presented. So having a strong data infrastructure to support also all the information is also a good way then to create other tools over the top of the written. The third tool that I would like to present is the cumulative effect assessment. This is actually what is the cumulative effect assessment? Is a systematic procedure for identifying and evaluating the significance of effect from multiple pressures and users and human activities over the marine environmental components. They can be habitats, the species, fish, mammals, and so on. And basically, it is from maritime spatial planning point of view, it is a great tool for incorporate the ecological aspect, the biodiversity, the decision, because it's combined the anthropogenic uses with the biological aspect. So it is one of the main tools to incorporating this information in the MSP process. So it can be used in the MSP process to define the current conditions, identify the issues, but also to investigate and evaluate alternative management actions. The decision that will be taken by the plan. It is a spatial explicit tool. As we will see in a moment, it provides maps. It tries to address the transboundary influence of this aspect. For example, if you have the marine traffic in some area, the impact can be, for example, the underwater noise that can spread over the area, influence also other countries, not just the countries where the traffic is present. And we also try to incorporate the land-based interaction. There are a lot of publication that started more or less in 2008 to use this tool as a strategic tool to support the market. In this process, we have developed our own methodology, framework, and software, which try to implement an explicit, what we call explicit geospatial impact change. So we started from the human activities maps, the maps that describe for the area of analysis, the distribution of different human activities, maritime transport, the presence of oil and gas extractions, and the type of these facilities, the coastal maritime tourism, the small-scale fishery, the trawling, and so on. These are the starting point. Starting from the human activities, we try to there is the first step of assessment. We are going to assess the pressures, combining all this information, the pressures, for example, the marine litter, the underwater noise produced from all these activities together, the input of organic matter, the abrasion, and the underwater noise repeated, sorry. These are pressures that are also defined from the marine strategy in order to have a joint aspect of the marine strategy. And then we are going to combine this map of the pressure with the presence of distribution of environmental components. For example, the presence of habitat and seabed, the nursery habitat, marine mammals, turtles, and so on, in order to incorporate the ecological knowledge and try to estimate the impact, the effects over this habitat, to produce this kind of map. So these are, just to recap, which are the input data. We have this kind of map that describe also, for example, in detail for some maps, the distribution of the trawling, that for the Adriatic Sea is the most important source of impact, the trawling over the bottom trawling, but also other map, the transport, the aquaculture, offshore platform. We are going to describe, to create this map for each kind of. There could be also some model, for example, behind this map, there are some models that start from AIS data and try to investigate the behavior of the vessels in order to estimate the fishing effort in the area. Then we have to collect information about the presence of the distribution of the environmental components, turtles, seabed habitat, nursery grounds, these are few examples. And then we are going to implement the first steps. So we are going to create this kind of map that you can see in the bottom left part. The distribution of abrasion that combine the abrasion due to different, or the distribution of contaminants or underwater noise and so on, but also using some hydrodynamic model in this part, collect information about the coastal cities and rivers. We are going to estimate the contribution to nitrogen and phosphorus in the area. So we can also inject in the models this specific output. Then basically, okay, this is based also using supporting, this activity can be also performed using some, we call it weights metrics, where the expert identify which are the main source of the different pressures, starting from the different uses. And finally, the second step, just to recap, is to incorporate the ecological knowledge in the model. This is one of the main aspects to do that at the strategic scale, is to use the sensitivity metric, where the expert or the, we can use the expert surveys, interview, literature review, or meta-analysis of the interview. Literature to define which are these contributions, or better, which are the sensitivity of each environmental component to a specific pressure. And it is a sensitivity-based assessment. It's the most common approach to use to work at strategic scale when we don't have other information. And basically, the sensitivity, we can define it as the likelihood of change when pressure is applied to an environmental component. And it could be a function of the resistance and the resilience of the habitat. Okay, these are the main results. The main result of the analysis, maps and graphs. Daniel will show you that later. We can also perform some more advanced analysis, like try to investigate which are the uncertainty, the tool that highlight in the best way for the stakeholder the impact change. We can do scenarios comparison to compare the differences between, for example, the current condition and the future condition after the implementation of the plan. And all this tool is implementing the geoportal I showed before. So this is another aspect. This tool can be run by non-experts. And we have applied this tool in some case study. Now I show you a couple. The first example, and I will leave the floor to Daniel to the other example. So the first case study, we have applied this tool for support the Italian maritime spatial planning process. This is for the Emilia-Romagna region. It's a pilot area where we implemented this pilot MSP plan. It's a quite crowded area. There are a lot of marinas, the fishing activities, 60 gas extraction platforms, you can see on the map. And the MSP process start to identify the issues using the tool, the cumulative effect assessment tool also. Propose a portfolio measures, and then try to, using the same tool, to investigate how it changes the impact over the area. And these are some results of this analysis. You can have this kind of map that show you, which in blue, the area where the impact is supposed to be lower in the future, and the red where the impact will be higher due to this kind of proposal of measure. For example, introduce some environmental protection area, or change the fishery and aquaculture position, and so on. This could be a result of the process. Now I leave the floor to Daniel.
Thanks, Stefano, for the presentation and for the very clear explanation of what is data infrastructure, what they are capable for. I would like just to highlight shortly two more case studies. One case study was done within the ESPON program, which is a program, a European program that supports the territorial cooperation and national regional territorial development policies. And within this program, we have been developing a case study which uses basically the cumulative effect assessment instrument, but instead of looking at the ecological receptors, it's trying to look at what are the potential effects for humans based on the pressures defined by the MS15, by Stefano. So the aim was basically to look at what are the risks from these multiple pressures for the recreational quality of beaches and for actually beach users. The method was based actually on analysis of these recreational values for over 600 beaches along the Adriatic coast. We have been looking at what's actually the contribution of the ecosystems to human beings, in particular of the beach ecosystem. So we have been basically developing indicator list with different measures of the quality of the beach in terms of landscape diversity, in terms of obstructed views to the sea, in terms of what is the recreational quality of the marine habitats they have there and the land uses, and have been basically developing a recreational supply map for each of the beaches based on different regions, Italian regions. At the second step, we have been looking what is the demand for the use of those beaches. Of course, monitoring 600 beaches is really difficult in terms of tourism flows. And therefore, we have been using actually social media, in particular geotag information from social media, from the social media Flickr. This is just an example. Maybe you have been to the Rialto Bridge in Venice. And this is an example of the geotag information in yellow with over 10,000 geotags of visitors going there. So it's a really powerful tool. And what we have been doing here is actually translating this information on the frequency and the number of users which are going to those beaches into a photo user days information to identify the frequency and therefore the demand, let's say the recreational demand of tourists to go there. One of the final steps was actually to couple this information, particularly the demand, and the human present to these areas, to these beaches, with the stresses of the MSFD and try to identify what sort of pressures can actually affect also human well-being. Translated into decreased naturalness for the beaches, the exposure to pathogens that may generate it from human activities at sea, and to reduce seascape attractiveness by construction at sea, oil and gas, but it could be also offshore wind energy development. And one of the results was basically that the regions, coastal regions that have much more industrialized sea areas or sea area activities, of course, are the ones that are more prone to risks for pathogen releases, sewage, blight waters from ships, and so on. This is usually located in the northern part of Italy, which is much more, northern Adriatic Sea, which is much more industrialized area. A second case study, what I would like to highlight, is a preliminary results. So what we have been doing is or what I'm doing principally, is developing a geospatial database of maritime activities for the exclusive economic zone of Spain, and incorporating and testing a cumulative effect assessment model using EMODNet data, but also national data set. So these are more or less the human activities we have been identifying. In particularly, we have seen many of them already by Stefano, but one of the important aspects is also that we are including future potential for offshore wind energy development through the POEM, so the Organización de Espacio Marítimo of Spain. We have been incorporating data from EMODNet for doing this. This is a fishery, this is the shipping density, this is the coastal tourism and sailing density activity, and of course, been adding geospatial data where it was possible from the impact, from the environment impact assessments on future offshore wind energy development. This is Tramontana, this is in Canary Island, a project, and this is the San Brandan project in Galicia. We have been also here for cumulative effect assessment. We have been using the environmental components. So therefore, at the moment, we have habitat data. So this is the habitat data for Spain. And we have been testing, let's say, a cumulative effect assessment for Spain. We have been, of course, then adding information on the sensitivity of the activities based on the environmental receptors, so therefore the habitat, and to what sort of pressure they are more sensitive, on a scale from 0 to 1. What is here interesting is that we've been then looking at the distribution here of the pressures and the different uses. And what is interesting is that one of the preliminary results is actually looking at shipping density and coastal tourism activities, and fishery is one of the most impacting activities at sea. So these are traditional uses. But of course, the model has the flexibility, and as far as we integrated geospatial information from floating offshore wind energy potentials, we can actually flexibly also incorporate new users and look at what is their potential impact at the marine environment. The approach is scalable. This means that we can do it from the exclusive economic zone for Spain, but we can scale it for this planning unit, which is one of the planning unit of the Organización de Espacio Marítimo. And here again, we have been mapping and incorporating future and offshore wind farm development, and it gets incorporated into the analysis for further evaluation. That's it, the conclusion, just really briefly. So marine spatial planning is a momentum, so it's a global process in different countries. It needs constantly new information to be better, to be more precise. On EU level, there are great efforts to systemize the information and to make it accessible to people, as we have seen, and to different stakeholders, as we have seen from Stefano. And the ecological knowledge integration in cumulative is a great challenge. It's the greatest challenge, and it's the data which is usually lacking for the analysis. Cumulative instruments, cumulative effect assessment instruments are actually used at the strategic planning level, but there are already cases in Sweden where the marine spatial plan in Sweden, the second cycle, is using cumulative effect assessment as operational tool to plan their sea areas. Human health, as we have seen in one of the case studies, is a fairly underrepresented aspect in this cumulative effect assessment, and also in particular in marine spatial planning. So this is definitely an area where further improvement can be done and can be actually contribute to a better understanding of the activities, of what the resources we human use, and how we can manage them more better. Preliminary application in the Spanish context is a testing case. However, there's a lack still of information on ecological features, which, and of course also in the sensitivity scores that we would need to improve with Spanish experts. The collection of data is basically lacking on this one, on marine activities, and also having the geospatial data of the second cycle of the marine spatial plan in Spain would basically increase the validity and probably also provide a new level of discussion, collaboration among the national community of researchers, but also decision makers. So thanks for your attention. Yeah. Any questions? Please.
Yes. You have been working with maritime spatial planning in several seas and oceans in Europe, in United Kingdom and Italy. Every country and every region has different activities and different environmental characteristics and probably different stakeholders. So for you, with your experience, what is the situation now in Catalonia or in Spain compared to the other areas? Are we lacking something, or what is the situation?
So from Catalonia, so I believe I answer. So my impression is, as being just a newcomer, let's say, and being introduced just recently on the topic in marine spatial planning in Spain and in Catalonia, my impression is that, of course, marine spatial planning is a completely new topic, and a new way of understanding and managing and planning an environment, especially the marine environment, is really a dynamic environment. And there's substantial need, I think, to it is a learning process for everyone, I would say. It's a learning process for stakeholders, for also the sectors that are involved in specific activity at sea. And I believe also a learning process for policymakers to get a better understanding and to get better improved decisions on how they want to develop and vision the sea space. So it is actually a process of defining a process of defining a vision on how a society on how a region wants to see their sea space, how it wants to be used, and how it wants to be exploited or sustainably and adaptively used in future. So, maybe you want to add something?
However, there is a lot of differences in EU experiences in respect to marine spatial planning implementations. There are some countries that are quite expert, like in the Baltic Sea. Maybe they already have, already know how the process works, that they already have implemented the first step of the analysis. And they also have the infrastructure at the basin level, transboundary infrastructures that support this process in the most efficient way. Infrastructure, I mean the data infrastructure, where all the countries can share the information and public information. However, there is country that have just started in the last 2 years to understand how to implement this process. So there is a lot of differences. But of course, this kind of project at EU level or the basin level is quite useful to share information and to start to collaborate also in ideas in how to implement practically this. So it's just to add some overview on the different situation in EU. So there are in IMONET, all the plan will be from the different countries will be published in the IMONET Human Activity Data Portal of the EU Commission. And for now, there are already 3 plans, just to give you an example of the different levels. It is Finland, Belgium, and another one, don't remember, maybe not German. Yeah, no, there is a new one, but there are 3 plans at the moment. So the other country have different level of maturity.
Any other question? Maybe from the online audience, is there anyone? Okay, that's fine. Yeah, please.
All of these tools are high data dependent, I think so. They depend about the data. And the problem is if you have one component and you don't have enough information, I don't know, for example, ecosystems and not, I don't know, if the tools are working without some component, the data of some component. Understand me?
To fill the gap.
Yeah, because you have a lot of relationships. And if you have several components, well analyzed and good data, but you have one component, biodiversity, just to say, and the conclusions and the suggestions are not adequate. I don't know.
Yeah. Sorry. Yeah, this is a very important question. Also to clarify, yeah, you cannot use the tool by itself and trust on the tool. And trust on the tool. Of course, there are a lot of preliminary work in one of the main approach that it is due. I have not mentioned it here. Maybe in some paper that I show, but not here in the presentation. One of the best approach to frame all this analysis to implement a risk assessment methodology in order, and this is quite useful to identify before to apply the tool, which could be the main risks for the environment, for the human well-being or sociological aspect. And based on this first analysis, they also try to tell you if you are forgetting something of important or not. This is one of the best approach to frame everything using this risk assessment framework. And this is exactly a good approach to tell you if you're going to forget something that are important, or you can trust of your analysis. Of course, if if you are forgetting something important, you have for sure to introduce some new data. Or another option is to be really to use the tool just to investigate not the entire aspect, but just some few aspects, and you have to be you have to know that there are this gap. However, the risk assessment framework as a global frame to put everything together is a good approach exactly to take in consideration this aspect. That is one of the main issues, especially not just for the pressure. We know a lot of in how, do you remember, we have two main steps, the pressure assessment and then the impact assessment. For the pressure, usually, it's not always this, but usually we have more information. We can put some monitoring station, for example, for the underwater noise, for the marine litter, and so on. There is the marine strategy also that can support in some cases, but for the biological aspect, there are a lot of gaps, and there are a lot of work to do in the future. The tools support the sensitivity uncertainty analysis that technically can address you in which is the most important source of uncertainty and prioritize your activity in order to cover these gaps. So there are some models that we can implement also to teach us in which are the most gap the analysis. So we have a couple of approaches to deal on this aspect, but of course this is a critical, really critical aspect of this methodology. And the tool it cannot be used as a tool itself, must to be incorporated in a comprehensive framework that also take into account the stakeholder, the experts that tell you which are the main risks a priori before to apply.
Maybe I just add that before actually applying the model within a marine spatial planning practice, so you have really to look at an inventory of what is there in my marine space in terms of what are the activities, what are the environmental components which are important, which are the habitats, the algal beds, which are all the infrastructure which is important, what are the biophysical processes that are relevant. And this is already a first step to understand what information we have, and what information we really need also in future to through research, to better monitoring, to better collaboration with scientific community, to get this data and to improve the knowledge base for our plans. So it's a continuously cyclic and iterative process as well in the data gathering activities.
Let's think about the cycling is another aspect. Using the tool instead to do the can exactly facilitate in this aspect. You don't have to worry about to rerun the analysis in the every procedure. You just update a layer with new information, and then the tool by itself will produce the new results. So the importance of the tool is also to facilitate the recycling of the rerun at each new information that can be available in the future. So that's why to automatize everything.
Okay. Last question.
That's a question. It's just a question for everybody. For me, it's terrifying. So your work is terrifying me with the maps, where you see that nearly all the sea is full of activities. And you see, for example, the marine protected areas of Camp de Creus, no? Or other marine protected areas, you see red colors there. I think it's a good way to visualize all what is happening. And what you are saying is that always a new layer is going on into your models. For example, now the offshore wind energy. Of course, we need it. No, we need but again, it's a new layer in the sea. So how the question is, for me, I am terrified to see. I don't know you as a ecologist. Red colors everywhere, and that the sea is full of activity. So we are taking it as a very anthropogenic point of view that the sea is the economy, the blue economy. But the blue economy can finally destroy us. I don't know what is your okay. That was a crazy reflection. So thank you. I don't know if somebody has Another question? Oh. So thank you very much for being here. And thank you.